Right now, in gyms across the world, something extraordinary is unfolding inside the human body that defies everything you've been taught about fitness and nutrition. Picture two people standing side by side on treadmills. The first person ate a carefully measured pre-workout meal an hour ago, exactly as their trainer recommended. The second person hasn't eaten in 14 hours. Common sense says the fed person should outperform the fasted one. Common sense says hunger weakens you. But watch what happens at the cellular level and you'll see a different story entirely. The person who ate is running on yesterday's dinner, burning through stored sugar while fat cells remain sealed shut like vaults with the alarms still on. But the person who skipped breakfast, their body has become a completely different machine. Growth hormone is flooding their system at 5 times normal levels. Fat cells have unlocked and are pouring energy directly into the bloodstream. Their brain has switched to a fuel source so clean and efficient that neuroscientists are still trying to understand why we ever stopped using it. And here's what shocks even the researchers who study this phenomenon for a living. The fasted person doesn't collapse. They don't fade. They don't hit a wall. Instead, they often report feeling sharper, more focused, more energized than they've felt in years. Their body isn't suffering from the combination of movement and hunger. It's remembering something coded into human DNA across millions of years of evolution, a survival program so sophisticated that modern science is only beginning to map its full potential. Walk into any commercial gym and ask a trainer about exercising on an empty stomach. 9 out of 10 will tell you it's dangerous. They'll insist you need carbohydrates for energy, protein before workouts, calories to fuel performance. They'll warn about muscle loss, performance decline, metabolic damage. And they genuinely believe what they're saying because that's what certification courses taught them, what supplement companies reinforce, what seems logical based on a superficial understanding of nutrition. But what if that entire framework, that complete nutritional philosophy governing how millions of people eat and train, is built on a fundamental misunderstanding of how human metabolism actually works? What if the body you're walking around in right now has capabilities you've never accessed because you've never given it the conditions to activate them? By the time you finish reading this, you'll understand exactly what happens inside your body when exercise meets fasting, why this combination might be the most powerful metabolic tool you've been ignoring, and how to use it safely without the mistakes that give fasted training a bad reputation. Let's start by destroying a myth so deeply embedded in fitness culture that questioning it feels almost heretical. That food you ate 30 minutes before exercising, the banana or protein shake or energy bar you consumed because you thought you needed fuel, it's not powering anything. Not yet, possibly not even during your entire workout. Here's why. When you eat, food doesn't instantly become energy. It sits in your stomach for 2 to 5 hours while gastric acids and enzymes break it down into smaller components. Then it moves to your small intestine where the actual absorption process takes another 4 to 12 hours depending on the meal's composition. The energy powering your morning workout doesn't come from your breakfast. It comes from what you ate yesterday or even the day before that. The nutrients are already stored in your muscles, your liver, your fat tissue. What you feel after eating before exercise, that psychological surge of readiness, that sensation of being fueled up, that comes from hormones and expectations, not from calories you just consumed. Your digestive system releases hormones in anticipation of incoming nutrients. Your brain associates eating with energy, but the actual fuel burning in your muscle cells during that workout was stored days ago. When you skip the pre-workout meal, you're not depriving your body of immediate fuel. You're simply removing a comforting illusion. Understanding what happens next requires grasping how your body stores energy in 2 completely different systems and why that difference changes everything about how you should think about fasting and exercise. The first system is glycogen, which is essentially glucose packed into dense storage molecules sitting in your liver and muscles. Think of glycogen like having emergency backup generators scattered throughout a large building. They're fast to activate, easy to access, require minimal preparation to start producing power, but they don't hold much fuel. They're designed for short-term use, not sustained operations. The average person stores roughly 1,600 to 2,000 calories of energy. That's approximately 1 day's of baseline metabolic function, enough to get through normal daily activities, enough to fuel a workout, but not enough to sustain you for extended periods. The second system is body fat, and this is where the metaphor shifts dramatically. Body fat isn't an emergency generator, it's a massive underground fuel reservoir that could power the entire building for months without refilling. Even someone who's relatively lean, sitting at 15% body fat, carries 50,000 to 100,000 calories of stored energy. That's 25 to 50 days worth of complete fuel just waiting to be accessed. Someone with higher body fat percentages could theoretically survive for months on stored energy alone, provided they had water and essential nutrients.
But here's the design flaw that traps most people in a cycle of constant eating without ever accessing their real energy reserves. Your body always runs the emergency generators first, always. Why would it do something that seems so metabolically inefficient? Because burning glycogen requires less biochemical machinery than burning fat. It's the path of least resistance. Your cells can break down glucose quickly with relatively simple enzymatic processes. Breaking down fat requires more complex metabolic pathways, more cellular components, more biochemical steps. So as long as those glycogen generators keep running, your body never bothers tapping into the main fuel reservoir. The fat accumulates year after year, layering itself across your midsection, your thighs, your internal organs, while your body keeps burning the same small reserves over and over again. You eat, you store glycogen, you burn glycogen, you eat again. The massive energy stockpile sits there unused, growing larger with each passing year. Fasting is what finally forces your body to open the main tank, and exercise while fasting is like opening all the valves simultaneously. The demand for energy spikes, glycogen reserves start depleting, and your metabolism has no choice but to access the fuel it's been ignoring. Let's walk through the precise metabolic timeline of what happens when you stop eating, because understanding this sequence helps you know exactly when to exercise for maximum benefit. In the first 4 to 6 hours after your last meal, nothing unusual occurs. Your body is still processing food, insulin levels remain elevated, blood sugar stays stable, your liver's glycogen stores are fully charged. Everything feels completely normal because metabolically, you're still in the fed state. Around hours 6 to 8, subtle changes begin happening beneath your conscious awareness. Blood sugar levels stabilize at a lower baseline. Insulin starts dropping from its post-meal peak. Your liver begins releasing stored glucose to maintain steady energy levels throughout your body. You're not hungry yet, not in any urgent way. You're just aware it's been a while since you ate. By hour 8 to 10, molecular sensors deep inside your cells start detecting the shift. 2 critical proteins become active, and their relationship determines your entire metabolic state. The first is AMPK, which functions like a cellular fuel gauge. When AMPK detects low energy availability, it rises. The second is mTOR, which normally signals cells to grow, build, and reproduce. When mTOR detects nutrient scarcity, it falls. This biochemical crossover, AMPK rising while mTOR falls, is the signal that your cells are transitioning from construction mode to efficiency mode. They're shifting from building new tissue to optimizing existing systems. Around hour 10 to 12, the real transformation begins. Insulin has dropped low enough that fat cells can finally unlock their contents. Think about what insulin does. It's a storage hormone. When insulin levels are high, it signals every cell in your body to store energy, not release it. Fat cells in particular are extremely sensitive to insulin. Even slightly elevated insulin keeps them locked tight. But after 12 hours without food, insulin drops to baseline levels, sometimes even below baseline. The locks release. Fatty acids begin flowing out of adipose tissue and into your bloodstream. Your muscles can now grab these fatty acids and burn them for fuel. Your heart prefers fatty acids and runs more efficiently on them. Even your brain, which people assume needs glucose, can derive significant energy from ketones produced from fat breakdown. The emergency generators are running low on fuel. The main reservoir is opening. Your metabolism is making the switch from sugar burning to fat burning. And if you exercise during this specific window, you don't just accelerate the fat-burning process, you trigger a hormonal cascade that literally rewrites how your body handles energy for hours, sometimes days afterward. Here's what the research shows, and these aren't small marginal differences we're talking about. Studies analyzing fasted versus fed exercise consistently demonstrate one result. When you move your body in a fasted state, fat oxidation increases dramatically. One comprehensive analysis reviewing multiple controlled trials found that aerobic exercise performed after an overnight fast can increase fat burning by 20 to 30% compared to the exact same exercise performed after eating. That's not a rounding error. That's your body fundamentally changing which fuel source it prioritizes. The mechanism is straightforward once you understand the insulin connection. When you eat before exercise, even a small meal, insulin rises. Insulin signals fat cells to remain locked. No matter how hard you train, no matter how much energy you expend, if insulin is elevated, stored fat cannot escape its cellular prison. Your body burns available glucose circulating in your bloodstream and saved glycogen packed in your muscles, but the stored fat, the energy you actually want to eliminate, stays trapped exactly where it was. When you fast, insulin drops to minimal levels, the cellular locks release, fat floods into circulation, and exercise creates immediate demand, pulling that fat directly into your muscle cells where it gets burned for energy. Your body isn't choosing to burn fat because it's the available fuel source, and you've created conditions where accessing it is the path of least resistance.
But fat burning, as significant as it is, represents only the beginning of what happens during fasted exercise. The real story, the transformation that might matter even more for long-term body composition, is what happens to your hormones. And one hormone in particular changes everything about how your body handles muscle and fat. Growth hormone is produced by your pituitary gland, a small structure at the base of your brain. It serves two primary functions that seem almost perfectly designed for what you're trying to accomplish. First, it signals fat cells to release stored energy, essentially amplifying the fat-burning effect we just discussed. Second, and this is crucial, it protects muscle tissue from being broken down for fuel. It's your body's way of saying, burn the fat, preserve the muscle, maintain the metabolically active tissue that keeps you strong and functional. Both fasting and exercise independently trigger growth hormone release through different pathways. But when you combine them, something remarkable happens that researchers are still working to fully understand. Studies published in endocrinology journals show that during extended fasting periods, growth hormone levels can increase 3 to 5 times above baseline. During high-intensity exercise, levels can spike even higher, sometimes reaching 6 to 8 times normal output. But when you fast and exercise together, when you activate this hormone from multiple pathways simultaneously, some studies have measured growth hormone increases of 5 to 14 times normal levels during combined protocols. Think carefully about what this means from an evolutionary perspective. Your body is sensing scarcity and physical demand at the exact same time. Food is unavailable and significant energy expenditure is required. In ancestral terms, this likely means you're hunting or fleeing or engaging in some survival-critical physical activity. So your body floods your system with a hormone specifically designed to protect muscle tissue while accelerating fat breakdown.
It's not entering starvation mode, where it desperately clings to every calorie and breaks down muscle for fuel. It's entering optimization mode, where it preserves what matters for survival and burns what's expendable. This is why people who consistently train while fasting often report maintaining muscle mass or even building muscle while losing significant fat body. It sounds physiologically impossible. How can you build tissue, which requires raw materials and energy, while eating in a deficit? But it's evolutionary programming that makes perfect sense once you understand the context. When food was scarce, your ancestors couldn't afford to lose muscle mass. Muscle meant the ability to hunt, to fight, to escape predators, to survive. Losing muscle during periods of hunger would have been a death sentence. So human metabolism evolved a mechanism to preserve muscle tissue even during caloric restriction, as long as physical demand signals that the muscle is still necessary. That mechanism still exists inside you today, waiting to be activated. Now, let's address what happens in your brain during fasted exercise, because this might be the most surprising part of the entire process and the aspect that convinces people to continue this practice even after they've achieved their body composition goals. Many people who train on an empty stomach report feeling sharper, more focused, mentally clearer than when they train fed. For decades, this was dismissed as placebo effect or imagination. People assumed that hunger should impair cognitive function, that the brain needs constant glucose, that mental performance must decline without food. But neuroscience research has proven this is biological reality, not psychological wishful thinking. Part of this cognitive enhancement comes from BDNF, which stands for brain-derived neurotrophic factor. Think of BDNF as fertilizer for neurons. It promotes the growth of new brain cells, strengthens connections between existing neurons, protects against neurodegeneration, and enhances learning and memory formation. Both fasting and exercise independently raise BDNF levels through separate mechanisms. When you combine them, the effect doesn't just add, it amplifies. Your brain isn't suffering during fasted exercise. At the cellular level, it's upgrading its own hardware.
Another factor is ketones, those small molecules your liver produces from stored fat after roughly 12 hours without food. Ketones cross the blood-brain barrier and fuel neurons directly. And here's what shocked researchers when they first studied this carefully. Your brain doesn't just tolerate ketones as backup fuel when glucose is unavailable. In many measurable ways, it actually runs better on them. Ketones burn cleaner than glucose, producing less oxidative stress and fewer damaging free radicals. They provide more stable energy output without the fluctuations that come from blood sugar spikes and crashes. Some researchers studying cognitive performance have found that ketone metabolism in the brain correlates with improved focus, enhanced pattern recognition, and better executive function. There's also norepinephrine, a neurotransmitter that spikes during fasting. It promotes alertness, sharpens attention, accelerates reaction time, and creates a sense of mental energy that people often describe as being wired but focused. Your body knows, at a deep evolutionary level, that hunger should make you sharper, not slower. Because if our ancestors became mentally foggy when they were hungry, they couldn't hunt successfully. They couldn't track animals, couldn't strategize, couldn't coordinate group efforts. They would have starved. The humans whose brains performed exceptionally well during hunger were the ones who caught food and survived to pass down their genes. You carry that exact programming. But this raises the critical practical question: what type of exercise should you actually do while fasting? The answer depends not on how hard something feels, but on which energy system it primarily uses, because that's what determines metabolic compatibility with the fasted state. Let's organize this differently than most fitness advice does. Instead of categorizing exercise by intensity or equipment or muscle groups, let's divide it by fuel source, because that's what actually matters when you're training without recent food intake.
First, there's fat-dominant exercise, which includes any activity you can sustain for more than 20 minutes without gasping for air or feeling like your muscles are burning. Walking at any pace, light jogging, cycling at conversational intensity, swimming, tai chi, easy hiking. At these effort levels, your body primarily burns fat for fuel, even in a fed state. Fat typically contributes 60 to 80% of the energy for these activities. In a fasted state, that percentage climbs even higher, sometimes reaching 90% or more. These activities are absolutely ideal for fasted training because your fat reserves are more than sufficient to power them indefinitely. Someone with average body fat could literally walk or jog slowly for days without depleting energy stores. Next comes mixed fuel exercise, where intensity increases enough that fat metabolism alone can't keep pace with energy demands, so your body starts pulling more heavily from glycogen stores. This includes moderate to hard running, where you're breathing heavily, but you can still speak in short phrases, cycling intervals, circuit training, CrossFit-style workouts, any activity where breathing becomes labored, but you can still maintain effort for 10 to 20 minutes continuously. In a fasted state, particularly after 12 to 16 hours without food, your glycogen stores are partially depleted, maybe down to 60 or 70% of capacity. So you might not hit your absolute peak performance. Your 1-rep max might decrease by 5%. Your sprint times might be slightly slower. But research shows something fascinating. After 4 weeks of consistent adaptation to fasted training, performance in these glycogen-dependent activities rebounds significantly. Your muscles learn to work efficiently with less stored fuel. They become better at mobilizing whatever glycogen remains. They develop metabolic flexibility that fed-state training never creates.
Now, there's one special consideration specifically for resistance training that changes the post-workout strategy. Weightlifting creates microscopic damage in muscle fibers. That's not a bug, it's a feature. That's the entire point. Your body repairs those tears and builds the muscle back stronger and larger than before. But repair requires raw materials, specifically amino acids from protein. If you lift weights and then continue fasting for many hours afterward, your body lacks the building blocks it needs for optimal recovery. So the intelligent strategy becomes clear. Train fasted to maximize growth hormone release and fat burning during the workout, but consume protein within 2 to 4 hours after lifting to provide the amino acids necessary for muscle repair and growth. You get the metabolic benefits of fasted training plus the anabolic benefits of proper post-workout nutrition. Now we need to address what happens after you break your fast, because your training approach should shift based on your metabolic state, not just an arbitrary weekly schedule. When you first start eating again after an extended fast, your body goes through a pronounced metabolic transition. Insulin rises from its fasted baseline, digestive processes activate, blood flow redirects to your intestines, energy gets diverted from maintenance functions to incoming nutrients. During the first day after breaking a fast, especially if it was longer than 24 hours, your system is recalibrating. This is when you want to focus on recovery-based movement rather than intensity. Walking, gentle stretching, light yoga, mobility work, activities that promote blood flow without creating significant metabolic demand. Let your body stabilize. As you continue eating over the next 1 to 2 days, glycogen stores gradually replenish. This process isn't instant. It takes 24 to 48 hours to fully restore muscle and liver glycogen, depending on what you eat and how depleted you were. During this refueling window, your insulin sensitivity is significantly elevated. This means your body handles carbohydrates exceptionally well, shuttling glucose into cells efficiently, rather than converting it to fat. If you want to include carbohydrates in your diet, this is absolutely the optimal time metabolically. During this refueling period, you can progressively increase training intensity. Start with moderate effort activities, light resistance training with higher repetitions and lower weights, moderate cardiovascular work. Your glycogen is rebuilding, so you won't be at full strength yet, but you can train productively and continue the adaptation process.
Once glycogen stores are fully restored, usually around the 72-hour mark after breaking a fast, you can return to maximum intensity training. Heavy compound lifts, all-out sprint intervals, high-volume workouts. Your fuel tanks are full, your hormones have stabilized, you're back to peak capacity. The key insight here is that intelligent training matches your metabolic state rather than following an arbitrary schedule. After fasting, prioritize protein immediately. Your body is primed for muscle protein synthesis. Insulin sensitivity is elevated. Growth hormone is still elevated for 24 to 48 hours after you resume eating. This creates a perfect anabolic environment. Eggs, fish, meat, legumes, Greek yogurt, any high-quality complete protein source works. Spread it throughout the day rather than consuming one massive meal. Your body can only process and utilize a certain amount of protein per sitting, roughly 25 to 40 grams, depending on body size and muscle mass. Now we need to address who should absolutely never attempt fasted exercise, because as powerful as this metabolic strategy is, it's not appropriate for everyone, and attempting it under certain conditions can be genuinely dangerous. If you're pregnant or breastfeeding, you're supporting another human life with your nutritional intake. Your energy demands are fundamentally different from a non-pregnant person. This is not the time to experiment with metabolic stress or caloric restriction. If you have any history of eating disorders, disordered eating patterns, or obsessive relationships with food, fasted exercise could trigger unhealthy psychological patterns. The restriction mindset can blur from strategic tool into dangerous obsession. Work with healthcare professionals instead. If you have type 1 diabetes or use insulin medication, blood sugar management becomes dangerously complicated when you combine fasting with exercise. Your glucose can drop to life-threatening levels. Medical supervision is absolutely essential. If you have chronic kidney disease, fasting adds metabolic stress that your kidneys may not handle well. If you're significantly underweight or have very low fat banks, you don't have adequate energy reserves to safely fuel fasted training. And if you're completely new to both fasting and exercise, don't start both simultaneously. Master one before adding the other. Warning signs to stop immediately and end your workout include severe dizziness that doesn't resolve within a minute or two of stopping movement, heart palpitations that continue after you finish exercising, confusion or mental fog where you can't think clearly, extreme weakness where you feel like you might collapse, or nausea and vomiting. If these symptoms don't improve within 10 to 15 minutes of stopping exercise and drinking water, end the workout completely. Eat something with protein and carbohydrates. Consult a doctor if problems persist. One critical point about hydration that prevents most problems people experience. When you fast, your kidneys excrete more sodium and water because insulin is low, and insulin normally signals your kidneys to retain sodium. This is completely normal, but it means you need to be intentional about replacing fluids and electrolytes. Many symptoms people attribute to fasting itself, fatigue, muscle cramps, headaches, dizziness, are actually from dehydration and electrolyte depletion. Drink water consistently throughout the day. Add a pinch of high-quality sea salt to your water. Use electrolyte supplements without added sugars. These simple solutions prevent most problems before they start. So here's the complete picture we've built. Fasted exercise isn't dangerous when approached intelligently, with proper preparation and awareness of your body's signals. Your body was literally designed for this across millions of years of evolution. When done correctly, you increase fat burning by 20 to 30% compared to fed-state exercise. You boost growth hormone 5 to 14 times higher than baseline, protecting muscle tissue while accelerating fat breakdown. You improve insulin sensitivity, which creates long-term metabolic health benefits that extend far beyond any single workout. And you enhance brain function through increased BDNF, ketone production, and norepinephrine release. The practical strategy is straightforward. Choose exercise intensity that matches your current fuel availability. Fat-dominant activities work best during fasted states. Mixed fuel and glycogen-dependent exercises require an adaptation period of several weeks. Start gradually and progress systematically. Pay attention to warning signs your body sends. Stay properly hydrated with adequate electrolytes. And after breaking your fast, prioritize protein intake to maximize recovery and muscle growth. That pre-workout meal you thought was fueling your training never provided immediate energy. The energy powering every workout has always come from stored reserves accumulated from previous meals. When you exercise while fasting, you're not depriving yourself, you're teaching your metabolism to efficiently access the massive energy reserves you're already carrying. You're reconnecting with evolutionary programming that modern eating patterns have buried under layers of constant feeding. So the next time you feel hunger before a workout, remember what's actually happening inside your body. Fat cells are unlocking their contents. Growth hormone is surging through your bloodstream. Your brain is switching to cleaner, more efficient fuel. You're not starving. You're activating ancient survival software coded into your DNA across countless generations. Your body doesn't need constant feeding to perform at high levels. It needs strategic challenge and adequate time to adapt. The capabilities have always been there, waiting for the right conditions to emerge.